Alright, so we saw how we would multiply any given number with 2 when it comes to binary representation, right? So what about other powers of 2, right? So what if I, let's say, want to multiply with 4, which is when expressed as a power of 2, it's 2 raised to the power 2. How do we multiply with 8, and how do we multiply with 16? Well, the process, it's exactly the same. You will move every bit to the left. So let's take an example of where we will multiply a particular number, let's say 20, with 4. Okay, I can't really take 80 and try to multiply it with 4, because using 8-bit binary representation, it simply cannot fit all. I mean, the number would be so big that it won't be able to fit inside 8 bits. Okay, so we already know that 20 times 4 is just going to be 80. So first let's write down the binary representation of 20. For that we will have 16, 0 and 4 and 0 0, and then 0 0 0 over here, right? So this is the representation of 20. Again, remember what is the power of 2 that gives us 4? We have to multiply with 4, right? So we have to look out for what is the power of 2 that gives us 4. It's the power of 2 that gives us 4 is just 2, right? So this power is actually what tells you about the number of steps that you will have to move every bit. Okay, so over here, since the power of 2 is 2, right? So the number of steps we will have to move this time is 2 steps to the left, not 1 step to the left. Okay, so let's go ahead and do that. So this 0 of course goes away. This 0 also goes away, because we want to move not 1 place to the left but 2 places to the left. So we actually start with the third last 0 that comes over here, then this one comes over here, and this 0 comes over here. Let me erase the previous zeros first. So yeah, then 0, then 1, then 0 and 0. As you can see, we don't really have any more digits to fill in the last 2 bits. For those we will simply add in more zeros over here. So the representation that we have now, as you can check it yourself, exactly represents 80 in denary. Okay, so we were able to perform multiplication by 4 by simply moving each bit 2 places to the left. So similarly, if I asked you to multiply any number, let's say x, with, let's say, some other power of 2, let's say with 8, so just remember that 8 when expressed as a power of 2 is given by raising 2 to the power of 3, right? So you will move, if you want to multiply by 8, you will move 3 steps to the left. Each bit will be moved 3 steps to the left. Whatever empty space is created on the right hand side, that is always filled with zeros. Okay, and any bit that finds no room in the existing 8-bit binary is simply deleted. In this case, in the example that we just did, these 2 bits were deleted because both of them were moved out 2 places to the left, and in that case they had no space in our binary representation.